Hello everyone, in this video we will learn about geometric progression, its nth term and the sum of n terms. What is a geometric progression, which is also known as GP in short? Actually it is a sequence in which every term is obtained by multiplying its preceding term by a constant. So we can say that a sequence in which every term is obtained by multiplying its preceding term by a constant. We can say, for example, suppose it is 2, 6, 18 and so on. We find that every term is being multiplied by 3. So we can write here that every term is being multiplied by 3. We can take one more example. Suppose it is 16, 8, 4 and so on. We find that every term is being multiplied by 1 by 2 to get the next term. And it's why we say here multiply by half. In other words, we can also say that a sequence A1, A2, A3 and so on is a GP in which we find A2 upon A1 is equal to A3 upon A2 is equal to A4 upon A3 and so on. It means the ratio of consecutive terms is same. That is a constant. We call it as R. We say that this ratio is the common ratio. After learning about the definition of GP, we will talk about the general form of a GP. We know that the first term of every sequence generally we represent by small a. So here also we represent the first term as a. Let the first term be small a. And the common ratio. And the common ratio BR. Then the GP will be, we can say the first term is A. We multiply R to get the next term, that is A into R. Multiply R again to get the next term, that will be AR square. Next term will be AR cube and so on, we can get the GP. So this can be said to be the general form of any GP. That is geometric progression. When we talk about the general term of it, what is the meaning of general term? That is a formula to find out any term of a GP. See, we have taken just now the GP is taken as A, AR, AR square, AR cube and so on. We write here the first term A1 is A. Can we write this as A into R to the power 0? Or we can also write this as A into R to the power 1 minus 1. When we talk about the second term of it, that is here A into R. Can we write this as A into R to the power 2 minus 1? When we go to the third term, that is AR square. Can we write this as AR power 3 minus 1? And so on. Same way, if we find the nth term of it, that will be given as A into R to the power n minus 1. What we find here, the number of term minus 1 is the power of R in every term. So the general term can be given as An, that is A into R power n minus 1. By this we can find out any term of a given GP. To understand the application of the general term, let's discuss some of the examples. Like first example we are taking is find the 10th term of the GP 3, 6, 12 and so on. To find out the solution, what we do here, we will write the GP which is given to us is 3, 6, 12 and so on. What is R here? To find out R, we have to see A2 upon A1, that is 6 upon 3, that is 2. We can also see A3 upon A2, that is 12 upon 6, this is also 2. Actually, this can confirm whether the given sequence is a GP or not. The first term here, A is given as 3. And now we know the formula to find out any term of the GP, that is the general term. We can write the general term AN is equal to ARN minus 1. Here n is 10 because we have to find out the 10th term. It means we can write here A10 will be A into R power 10 minus 1. That is A into R power 9. Substitute the values of A and R. A is 3, R is 2 and we know 9th power of 2 is 512. If we multiply, we are getting 6, 3, 15. It means we can write here the 10th term is 1536. So like this, we can find out any of the term of the given GP by applying the formula of the general term. We discuss one more problem based on the general term, that is find the GP whose second and sixth terms are 15 and 1215 respectively. Since we have to find out the GP, first of all we have to consider the GP. So we write in the solution, let the GP be, we will take the general form of GP, A, AR square and so on. We know the formula for the general term. We will write here general term is given by AN equal to ARN minus 1. According to problem, here we are given the second term, that is A2 and this is A into R, that is equal to 15. So this becomes our first equation. The sixth term, that is A6 is A into R to the power 5 according to this formula of general term. That is equal to 1215. This becomes the second equation. We can find the values of A and R by solving these two equations. So what we do, we dividing equation number 2 by 1. We divide second equation by first. We will be getting here AR5 upon AR is equal to 1215 upon 15. A cancels A. This 15 cancels this 15 8 120, 15 1 15. It means we are getting here R to the power 4 equal to 81 because R power 5 upon R is R to the power 4. And we know that 3 power 4 is equal to 81. This gives us the value of R as 3. When we get the value of R as 3, we can substitute that in 1. Substituting in 1, we get A into 3 is equal to 15. It means we are getting A is equal to 15 by 3, that is 5. After getting the values of A and R, we can find out the GP. Therefore, the GP is what? 5. Then multiply 3, 15. Multiply 3, 45 and so on. And this is the answer. So like this, in case we are given any two terms of a GP, using the general terms formula, we can find out that GP. Now we will learn to find the sum of n terms of a GP. The GP is given to us as A, AR square and so on, and there are n terms in this. To find the sum, what we do, we consider the sum to be sum of n terms. Suppose it is given by S. Will that be A plus AR plus AR square plus so on. And what will be the nth term? We know the formula for nth term, that is A into R power n minus 1. We can write here, since An is equal to ARn minus 1. This we can write as number 1. Now if we multiply on both the sides by R, multiplying R on both sides, we get here S into R, and this will be here A into R, this will be A into R square, this will be AR cube, and here we find the last term will become AR power n. Before that the term will be ARn minus 1 or not. This we can write as second equation. Now if we subtract second equation from first, we can write subtracting equation number 2 from 1. We will get here S minus S into R. And here you can see the second term cancels, third term cancels, so on till here the terms will be cancelled. And we will get here A minus AR power n. If we take S common from here, this comes as 1 minus R. And here if we take A common, here it is 1 minus R power n. Are we getting from here that S is equal to A into 1 minus R power n upon 1 minus R? This becomes the formula to find out the sum of n terms of a GP. But generally we use this formula when R is less than 1. In case R is greater than 1, there is nothing else we are doing in this. We can take minus common from the numerator. This will be minus A into R power n minus 1. Here also we take minus common. It will be R minus 1. Minus minus cancel and it becomes A into Rn minus 1 upon R minus 1. So the formula is same, only to avoid the negative sign we can use this formula for R greater than 1. To understand the application of the formula of sum of n terms, we take one example, that is find the sum of 8 terms of the GP 6, 12, 24 and so on. To find the solution, what we do, first we write the GP here which is given to us, that is 6, 12, 24 and so on. Here we find that the first term is 6 and the common ratio R we can see easily, that is 2. We find here R is greater than 1. So we will apply the formula for the sum of n terms which is applied for R greater than 1. And that is here Sn equal to A into R power n minus 1 upon R minus 1. We have to find out the sum of 8 terms, so we can write here S8 will be equal to A into R power 8 minus 1 upon R minus 1. Then we substitute the values here. A is 6, R is 2 upon 2 minus 1. So are we getting here 6 into 2 to the power 8 is 256 minus 1 upon 1. It is 6 into 255. When we multiply, this is 6 5 is 33, 6 5 is 33, 6 2 is 12 and 3 15. So the sum here comes as 1530. Like this we can find the sum of any number of terms which is given to us for a given GP. In the next video, we will learn about geometric means and their properties. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.